Okay, for example 2, we need to use the fact that corresponding parts of congruent triangles are congruent. So if we know the triangles are congruent, like we know triangle ABC here, they're telling us is congruent to triangle XYZ, then we need to know the corresponding sides are congruent. So here are the 3 sets of corresponding sides, and then the corresponding angles are congruent as well. So the corresponding parts of congruent triangles are going to be congruent. So if we look at example 4.2 now, okay, on mine we have a rectangle. Okay, and Allie's going to cut 2 triangles from a rectangular piece of metal along a dashed line to make earrings. How can Allie show that the earrings are the same size and shape? Well, rectangles are quadrilaterals. And again, we haven't talked about them, but opposite sides of a rectangle are congruent. So we have 2 sets of opposite sides that are congruent. And rectangles are defined as having 4 right angles. So the right angles are going to be 90, 90, 90, and 90. Okay. And then Allie is going to cut. So if we put the points on there, B, A, D, C. Okay, Allie is going to cut this along this dashed line. Okay, so if I draw the 2 triangles separately, we're going to have B, A, D. Okay, and we know this is a right angle. And we have 1 hash mark on AB, and we have 2 hash marks on AD. Okay, and then if we draw this triangle BCD, so BCD, okay, CD is going to have 1 hash mark, and BC has 2 hash marks here, and we know this is a right angle. So we know, based on the fact that it's a rectangle, that AB here is congruent to CD. That's 1 pair of sides that's congruent. So there's a 1 pair of sides that's congruent. Okay, we know that AD is congruent to BC. So there's a second pair of sides. AD is congruent to BC. And we also know that angle A is congruent to angle C because they're both right angles. So angle A is congruent to angle C. Okay, so that's 1 pair of angles congruent. So here, given to us, we have 2 pair of sides that are congruent and 1 pair of angles. So as long as that pair of angles is included, meaning it's between the 2 pairs of sides that are congruent, and they are, right? A and C are between the sides we're looking at. Then we have side, angle, side. Okay, there's the first side. Here's the angle. Maybe I should do that in different colors. Right? Right, side. Then we have angle, and then a side. So it goes side, angle, side. Right? Side, angle, side. Side, angle, side. Okay, so we know by the side, angle, side theorem here that, or postulate, or criterion, whatever you want to call it. Again, it's all semantics. Whether you want to call it a theorem, a postulate, or criterion, it doesn't really matter in the end. The idea is if you have 2 pairs of sides that are congruent, and the angle between those 2 pairs of sides are congruent, we know the triangles are going to be congruent. That's the important part here. Okay, if you look at your triad, and again, this is annoying because I have to erase everything. But let me help you out with your triad here. They're giving you 1 pair of sides that's congruent. Right, they're telling you AB is congruent to CD. Okay. My advice is to draw the 2 triangles separately. So actually, let me refresh so it clears away all the writing I have. And we'll go through the whole thing here because Again, they don't really give you many examples to work with, which isn't, pretty frustrating. For how much the school paid for the program, it's pretty frustrating that they don't give a lot of good examples. Okay, so let's go over to the Triad. Okay, so first thing you should do is draw these triangles separately. Okay, so D, A, C. Okay, and then the other one over here is going to be, here's A, C, and B. Okay, let's put in our hash mark here. We have DC is congruent to AB. So we can even write that out here. DC is congruent to AB. Right. And then AC is part of both triangles. So, and again, we haven't talked about this because, again, it hasn't appeared in the program, which is, again, very frustrating. But we can use the reflexive property. So AC is part of both triangles. So we know AC is going to be congruent to AC because it's the same thing. It's the same segment. AC in this triangle is going to be the same length as AC in the other triangle. So we also know that AC is congruent to AC. And if we need a property for that, that's going to be the reflexive property. And we'll get to that when we talk about some proofs. Okay. So we want to use side angle side. So right now we have two pairs of sides, which means we're going to need to do the included angles here. So we're going to need angle A from this triangle and angle C from this triangle to be congruent. That's these two angles here. And they are going to be congruent. That's going to be the alternate interior angle theorem, right? Our lines here are parallel. AB is parallel to DC. And so if you have a transversal AC here, your alternate interior angles are going to be congruent. So angle BAC is going to be congruent to angle DAC. I'm sorry, DCA. Okay, so now you have side angle. Side will tell you your triangles are congruent. All right, so here's one pair of sides, one pair of angles, and one pair of sides that are congruent. Okay, so now we know triangle DCA. And again, there's 6 different ways to name that first triangle. But triangle DCA is going to be congruent to triangle. So DCA is going to be congruent to triangle BAC. Right, D corresponds with B in this one. C in this triangle corresponds with A in the other one. And then A in this one corresponds with C in that one. Okay. And since those triangles are congruent, we know the corresponding parts are congruent. So we can say that angle B here, right, angle B is going to be congruent with angle D, because we know the triangles are congruent, and therefore the corresponding parts are congruent. So triangle D here, angle D here would be congruent to angle B. So therefore, angle D is congruent to angle B. Okay, so again, AB was congruent to CD. This was given to us. Okay, we knew AC was congruent to AC. That's the reflexive property. Okay, and then angle BAC is congruent to angle DAC. That was the alternate interior angle theorem, right? Alternate interior angle theorem. Okay, and since we had side angle side, that showed our triangles were congruent by side angle side. And since our triangles were congruent, the corresponding parts are congruent, so angle D would be congruent to angle B because D corresponds with B in the other triangle. Oops. All right, we could add corresponding parts of congruent triangles are congruent.